Yo, 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 this is Mr. O. Yo, 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 this is Mr. O. And today we're going to learn about classifying triangles. What about triangles? Tri means three. There are three angles, there are three vertices here. That's why we form a triangle, and there are three sides involved. And today we're going to classify them by angles and by its sides. So let's go ahead now. So classifying triangles by angles, we look at the figure of a triangle, and if we have three acute angles, that means it's called acute triangle. If we have one obtuse angle that is more than 90, between 90 to 180, that's going to be obtuse triangle. If we have one right angle, means say it's 90-degree angle, that means it's called right triangle. And if we have three congruent, means say all the angles are equal measure, then that's called equiangular triangle. Okay. Now, let's classify each triangle in the diagram below by its angle. So let's go ahead now with triangle CDE. Triangle CDE. There's a box there, that means it's 90. So this one here is called right triangle. Next, BCE, triangle BCE. Where's BCE? BCE. You can tell that angle C here on this triangle is big, and it's going to be an obtuse angle. So this is called obtuse triangle. Next, triangle ABE. ABE. Those arc on this triangle here means they're all equal. So we have equiangular triangle. Next, we have triangle BDE. BDE. And you can see that angle E here is more than 90. So therefore, that's going to be an obtuse triangle. And next is triangle CFE. That's CA. CFE, that's less than 90. So we know it's going to be acute triangle. Very simple, right? To classify triangles by its angles. Let's go now here, classify triangles by its sides. If there are three congruent sides, we call it equilateral. Lateral means side, triangle. If we only have two triangles that are congruent sides, that's called isosceles triangle. No congruent side, that's called scalene triangle. Let's classify each triangle in the diagram below by its side. Triangle JKM. JKM. I have one thick line here. There are two thick lines here, but this is unknown and nothing over here. So this is an example of scalene triangle because there's no equal side there's no equal side on this triangle. KLN. KLN. I have here two, and this is one arc. So therefore, there are only two sides that are equal. So this are called isosceles triangle. Next, we have JKN. 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 That's obvious that they're all sides are equal. So therefore, that's called equilateral. Oh, sorry. That's ugly. Equilateral triangle. Okay. Next. Let's try this example here. If classify each triangle by its angle and side. So here I have by angle, I know I have a right and isosceles triangle. I know I have a 114 here, so that's obtuse. I do not know if any of the sides are equal, so I know this is an obtuse scaling triangle. I know this is 60, 60, 60, so 7, 7, 7, so it's equilateral and equiangular triangle. 15, 18, 20, none of them are equal, so this is a scaling and acute triangle. I have a 90-degree angle here, so I know it's right, and none of them are equal, so the right scalene triangle. And I have your 97, which is an more than 90, so it's obtuse. I have a 5 and a 5 here, so they're equal, so it's going to be obtuse isosceles triangle. Let's try the example here. If PR bisect angle SRT and U is the midpoint of RT, classify each triangle by its angles and side. So if PR, where's PR? PR is this purple line and bisect SRT, SRT. So if this angle is 30, what do you know about this side here? That's going to be also 30. So this is 30 here. Okay. U is the midpoint. U is the midpoint of RT. So this is going to be equal to that one. Okay. Classify each triangle by its angle and its side. Okay. So UQR. Where's UQR? UQR. Okay. Since this is one thick line, that's also one thick line because it's a midpoint. And these two here equal, that's 30 there. That's going to be 120 plus 30 is 150. So this is also 30. So therefore, I have here an obtuse triangle. Obtuse and two sides are equal. So it's going to be obtuse isosceles triangle. Let's try the other one. SRT was SRT. RST, RST, RST. There you go. I have a 60 here, I have a 60 there, and this is 30 to 60. So we have equiangular. Let's see the side here. That's 8, that's 8, that's 16, this 8, and this equal to that one, that's 8. So it's also equilateral triangle. Okay, very easy, right? Let's go now to SRQ. 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 I have a box here. That means it's 90. So I know it's going to be a right triangle. And I have 8, 16 here. I don't know what is this. So it's going to be scalene triangle. PRT. Where's PRT? PRT. Okay, I know that this 8 also, so that makes it 16. So I know I have a isosceles triangle here. And this one here is bigger than 90, so I know it's going to be obtuse triangle. All right, let's move on now. So here, let's classify the triangle in a coordinate plane. Okay, we know that find the measure of the sides triangle JKL, then classify it by side. So we know that triangle has 3 sides. So let's do it. Let's graph it first. -7, -7, somewhere right here. -9, 1, and -1, -1. So this is my triangle. And this is the J. No, it's not a J. This is my J. This is my K, and that's my L. And I'm going to try to find the side JK, KL, and JL using distance formula. So let's do the JK here. JK will be -9 minus or plus 7 squared plus 1 minus or plus 7 squared there That will give you negative 2 squared is 4. 1 plus 7 is 8. 8 squared is 64. That will give us square root of 68. So JK is square root of 68. All right, let's try KL. KL will be square root of negative 9 plus 1 squared, and then what is this? 1 plus 1 squared. Kind of similar, right? Negative 8, negative 9 plus 1 is negative 8 squared. That will be 64. 1 plus 1 is 2. 2 squared is 4. That will give me square root of 68. So you know they're equal. So KL is square root of 68. Let's try JL. 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 So negative 7 plus 1 squared, and then plus negative 7 plus 1 squared. That will give you negative 7 plus 1 is 6 squared. 6 squared is 36. Negative 7 plus 1 again is another 36 here. So that will give you a square root of 72, which is not equal to 68, which is fine. But the idea is that we know that this sides are equal. So we have here an isosceles triangle because JK is equal to KL. Okay, there you go. If a triangle ABC is an equilateral, equilateral means all the sides are equal. Solve for both x and y. So therefore, all the sides there are equal because all of them, or because it's an equilateral triangle. So I can solve 3x plus 1 is equal to 49. And the other one is 18y minus 41 is equal to 49. Solve for this, subtract 1, subtract 1. That gives me 3x equal to 48. Divide by 3, divide by 3. X equal to 116. And plus 41 here, plus 41 there. That will give me 18y is equal to 0, carry 1, 90, divide by 18, divide by 18. So y is equal to what? 20, 5? I think it's 5, right? Okay, there you go. Kaboom. Next, if triangle DEF is an isosceles, isosceles means two sides are equal and DE is congruent to EF, so therefore these two here are equal. So I can say that 8x minus 13 is equal to 5x plus 17. So for the x here, I'm going to move the 5x to the right, make it 3x, move the 13 to the right side will give me 30. Therefore, x equal to 10. But there's a question, find the measure of each side. So I need to plug in the 10, the value of x, to all of the x on the problem. 8 times 10 minus 13, that will give me 80 minus 13 will give us what? 67. If this one here, if DE will be 67, if DE will be equal to 67, we know that FE has to be equal to 67 because they are said to be congruent. If you don't believe me, try to plug in the 10 to the 5x plus 17. It should give you the proof that they are equal. And DF, plug in the 10 there. So DF here is 10 plus 21, or DF is equal to 31. And there you have it. We found the side of all the measurement of this triangle. All right, last problem here. Triangle STU is an equilateral. When you say equilateral, all triangles are congruent. So we have a triangle, let's say STU. They're all equal. If ST, okay, here we go. ST is one less, meaning say one less is subtract 1. Where do you subtract 1? Twice the x. Twice the x. Okay. SU is 37 less, so minus 37 less than 5 times x, so 5x here. What about TU? TU is 11 more, so plus 11 more than x. Find the measure and of each side and find the x there. Since they're all equal, because it's equilateral triangle, I just have to pick two sides to be equal. So I'm going to put 2x minus 1 equals x plus 11. I'm going to move the x to the left, minus x here. That will give me x. I add 1 here, add 1 there. So x is equal to 12. Now I'm going to plug in the 12 to all the equation here. So 2 times 12 minus 1, 5 times 12 minus 37, and 12 plus 11. That will give me 24 minus 1, which is equal to 23. And I know for the fact that all of them will be 23. So because there is equilateral triangle, so all the sides will be equal to 23. And there you have it. And that's how you classify triangles by angles and the side. As always,